Hello guys, we're going to be talking today's video. We're going to be talking about the iron ion and its transport and its reserve. So iron ion can be transported as a free toxic into the cells. One of the main ways that iron does it is that iron +3 will have a higher affinity than the +2, and this will cause it to bind with the transferrin molecule. Once it binds to the transferrin molecule, it can then form the ferritin molecule, which in the serum, apotransferrin can bind to Fe3+, and then it can be converted into Fe. It can be converted to transferrin. Once it converts to transferrin, it can then bind to receptors in the cell and be internalized. Another way of transport is going to be through the apoferritin. So now there's no trans. So the first method was using the transferritin. So let me just make that a bit apotransferritin, which then goes on to form the transferritin. So that's one of the methods. And the second method of transportation is going to be the ferritin. So there's going to be no trans over here. So this is the one key things that I want you guys to look out for. So so they're basically in the cells, the apoferritin combines with the iron, and this is gonna be, and then it's gonna be a ferritin. Ferritin will bind to its receptors, and it's gonna be stored iron as iron 3 hydroxide, iron 3 oxide hydroxide, and keeps it soluble and again toxic. Accumulation of iron 3 oxide hydroxide will form a brownish pigment called the hemosiderin. So this is the main things I want to talk about the iron ion. The next thing I would like to talk about the iron ion is a bit more. I talked about its transportation, so that's a really important thing about the iron ion. But we can really divide its function to hemenic and non-hemenic. So hemenic can be those that are going to be involved in the for instance, you can say cytochrome C, cytochrome, and this is going to be for the oxidative phosphorylation of the Fe3+3. In addition to that, there can be a catalase enzyme. Catalase enzyme can be for the H2O to the H2O and the oxygen, and essentially over here what's going to be formed is that these iron radicals will be formed in this in these reactions. And then another form of hemenic function. Like I said, there's going to be a reaction about the catalase, and from here, what happens is basically Fe2+ will get oxidized. So when it gets oxidized, it's going to form Fe3+. Another function over here can be the myoglobin. Again, this is kind of place like where it can be stored or transferred. And a myoglobin, and there's going to be another one. I believe it's called transferrin, if I'm not mistaken. Sorry guys, not transferrin. It's going to be hemoglobin. So myoglobin, hemoglobin. And now what can be the non-hemenic? Non-hemenic can be the pH dehydrogenase. In addition to that, there can be not even NAD dehydrogenase. It can be also other types of dehydrogenases, such as the succinate dehydrogenase, and then the xanate oxidase. And now I want to talk about the consumption of this. So how much should you consume iron? So everyone, it depends. Women, if you're a child, the woman or a child, or if you're in child of so basically in women of childbearing, a woman like in child age, or you're in a pregnancy. So every single it really does differ. So it's gonna be from men will be 1, and to pregnancy it'll be milligrams per day. So that's it about that in the consumption category. And how about if there is overdose or deficiency? So I want to talk a bit about deficiency. I want to talk first of all about the absorption. So absorption, where does absorption occur? Well, it occurs in the duodenum and the upper parts of the duodenum, So you can mainly remember it's mainly the absorption will mainly occur in the GI tract, and this is mainly in the duodenum. Ascorbic acid causes ascorbic acid is going to cause an increase in digestion. So that's why they say, like, always eat some lemons to make your iron digestion much more better. And what causes a decrease in digestion can be a decrease, I mean, mention that over here, will be your phosphates. Because I don't really know the reasoning why this causes a decrease, but this is the main reason why it causes a decrease. And this is going to be in the absorption in the of course the GI tract. It involves the enterocytes, and enterocytes will then go for the iron reserves and for the erythropoietic activity, which occurs where? Well, that occurs in your in majority, if not all of it, at least in the human body. In the fetus it occurs somewhere else, but it occurs in the bone marrow. But in the fetus, where does it occur? Where let me tell you that also. Well, it can occur in the yolk sac. This is going to be in the very early development, or in the liver and spleen. Very important areas to mention. Yeah, and I want to talk about now. I want to move over to the deficiency of iron. So iron, as we know, is going to be an important part of. This is some background information. Part of hemoglobin. We already know that. We said hemoglobin, myoglobin, and many amounts of enzymatic activities. And I want to talk about what are the causes of this, and I want to tell you about these symptoms. Just basic two things. So if you have less blood, so something like you have a bleeding, that means you're going to have a deficiency of ironing, of course. So hemorrhage is also a important type of bleeding, because this is type of like an internal type of bleeding. And I want to talk about the symptoms. What are the symptoms that involve iron deficiency? Well, the symptoms that involve iron deficiency would be like you would of course have fatigue. You'd be fatigued, of course, and also anemia. Because if you have one type of, it can cause microcytic anemia. This is a form of anemia, whereas deficiency of, you're going to have deficiency of hemoglobin in anemia. There'll be a deficiency of hemoglobin, which causes what? Well, that causes a microcytic anemia, meaning your red blood cells will be smaller than usual. Also pregnancy, because the fetus requires it. Pregnancy can be a huge, and you're gonna, because maybe in your diet you don't have much iron. I want to talk about a bit about the overloads. The overload can be divided into two things. So as we previously said over here, when the transferrin, the apoferritin is converted to the ferritin, and the ferritin binds to the cell, that means it can be it'll be stored in the cell as iron 3 hydroxide. This is how it's going to be stored in the iron 3 oxide hydroxide. So this is how it's going to be stored, and we can see this is going to be something to do with the hemosiderin. So when you have a lot of hemosiderin, this is going to be, you're going to have a lot of brown pigments in the body. Another one is hemochromatosis. Essentially, hemo will be blood, chromatosis is going to be darkening the skin, and osis is going to be, of course, ptosis is going to be a disease. So when you have over amount of accumulation in the body, and this can cause a toxic effect, over accumulation, this can cause a toxic effect in the body, such as, like, you can have damage to tissues. What tissues? So you can say kidney, pancreas, wherever it's stored, essentially. So it can cause cirrhosis of the liver, cirrhosis. And guys, this is about it for me. This is R9. I hope you guys liked this overview about it, and hope please do subscribe to see similar content in the future. Thank you for watching.